Hello everyone, welcome you listening. My name is Huilin Zhao. Today we're talking about functions 11. Chapter 6, Sinusoidal Functions. The topic is exploring transformation of a sinusoidal function using Geogebra. And for the standard form gx equals a f k x minus d plus c, by applying the transformation from the sinusoidal function fx equals sin x, then new function is called gx equals a sin k bracket x minus d bracket plus c. When using transformations to graph, you can apply a and k together, then the c and d together. The values of a and k change the shape, but the values of d and c change the position. Step by step. For a, it determines the vertical charge or compression and whether there is the reflection in the x-axis. For k, it determines the period is increased or decreased, and whether there is the reflection in the y-axis, and t equal to 1 over k. Number third, for d, it determines the horizontal translation. If d more than 0, the graph is translated d unit right. But if d less than 0, the graph is translated d unit left. The last one, for c, it determines the vertical translation. If c more than 0, the graph is translated c unit up. If c less than 0, the graph is translated c unit down. Next, we're talking about a and k in details. The value of a determines the horizontal charge or compression and whether there is the reflection in x-axis. If a more than 1, the graph of it is charged vertically by factor a. If a more than 0 and less than 1, the graph is compressed vertically by the factor a. When a less than 0, the graph is reflected in the x-axis. The value of k determines the horizontal charge or compression and whether there is a reflection in the y-axis. If k more than 1, the period is increased by a factor 1 over k. If k more than 0 and less than 1, the period is increased by the factor 1 over k. When k less than 0, the graph is reflected in the y-axis. For example, we changed AKDC one by one. Use sin function fs equals sin s. So if you change a, get a gx equal a times sin x. If change k, get a hs equals sin kx is the whole angle. Change d, the px equals sin bracket x minus d bracket. Change c, let the arrow x equals sin s plus c. Now we're going to go to the Geogebra to explain the process of transformation. Now we go to the website. The web address is geogebra.org, the classic. And then first one, input the function, the sin function. So we can see this graph here. Is the period is 6.28. There's 2 pi, and is the maximum point here. And the maximum value is 1. And negative is the minimum point. We can see the special point here. and b from the 0, 0. b g is 1.57 and 1. This is the pi over 2. This is 90 degree. Here c is pi is 3.14 and h here 4.71 and -1. Here is 3 times pi over 2 and d is the end of the whole period and then 2 pi and 0. Next we're going to change a, so we set delete that one first. Input another function f as equal like the a times sin s. Here get a. Here a is 1, so the ps and fs are same. So right now we change when a is -1.5, so it's the reflection with x-axis, right, the purple one. And actually this the parity the same. Okay, next we change a to 1.1, 1.5 here. So you can see this one is the maximum point, is the minimum point. Okay, and change more than 1. So this 4.2, here is 4.2, positive 4.2, this is the maximum, and the minimum is negative 4.2. And change, and here is a is 0.6 here, so this maximum point is 0.6, the minimum point is negative 0.6. Right now you can see special point and the critical point. So you can see this b from b, g, c, h, d, this one period, and the maximum point is g is 1.57 and 1, and h is the minimum point. It's 4.71 is -1. Yeah, there's a change a. Next, you're going to change k and delete that one. We're going to input like the x sin x kx. Right? Here's k. Here k is 1, so the two functions same. Okay, right now change k less than 1, so this is too big. Here. That is the negative 0.9, so this reflection. The reflection is by the y-axis. This one, this green one here, and it's the parent function like this one. So it's left side and right side exchange. So here, like this one, 0. Yeah, this actually this left side and right side exchange is -1, right? And here, change more. right now k is 0.9, so the 1 over k is more than 1. We can see this one is the period is increased right here, and the parent function, the parent is from here, is gray. When k is less than 1, the period is large, and change. When k is 1.7, this is more than 1, so we can see this, the period is decreased because 1 over k is less than 1. And now we can check this critical point. Yeah. To the critical point here, so we get this from R to E, R 0, 0, and E is 3.7, so this period is 3.7, because 3.7 equals 1 over 1.7, and the maximum and the minimum point is arrow, minimum point is m, so the arrow here 0.92, J is 1, J arrow M is same, this is maximum point. So its maximum value is 1 and negative 1 is M O, and the M is negative 1, this is minimum point. Okay, and next we are going to change D, so I'll delete that one. D, so H equal sin x minus 2, minus 1 here. So you see this one. That means the graph move right side 1 unit. Move right side by 1 unit. And the period are same. And the maximum value and minimum value are same with the parent function. And next we are going to input s equal sin x and d. Yeah. So we're going to change d. When d is negative 0.6, I'm going to hide it. Okay. When d is negative 0.7, so it's move left side 0.7 unit, and we're going to change. So when d is 2.1, that means the move right side. Right now is 2.7. Let's change d. And check this the special point, and for this one, B is the negative 0.34. And here G is 1.23, negative 1. H is 4.37, positive 1. So its maximum and minimum value same with the parent function. And next, we are going to change C by the sin x plus C. So I'm going to change C here. If C is negative 1.3, that means move down 1.3 unit. If C is more than 0, is 2.1, just move 2.1 unit. Okay, and then we can see this special point. And the C is 1.570, 3.1, and the D is 4.71, 1.1. Where is the axis of symmetry? The symmetry is 2.1, the C. So try to draw this one. Okay, here this G is in the axis of symmetry G, 2.1. So it's going to change A, K, D, C. And then next, we're going to use and Fs equal to sin x plus 1 or plus 3. So right now I set is the axis of symmetry y equals 3. So okay, next we are going to find a special point, the critical point here. C is the maximum point, D is the minimum point. C is the maximum value is 5, and D is minimum value is 1. So because 2 plus 3 is 5, negative 2 plus 3 is 1, so you can get it. And then from here to here, and from C to E is 1 period. Okay, the C is 0.57, the E is 6.85. This one 6.85 minus 0.57 is 6.28. So because K is 1, so its period same. It's 2 pi, right? It's you only change A, C, D, and then for D, this move left side 1 unit, and the C is 3, so to move up 3 unit, and so they change the maximum point and minimum point, and the period are same. So all above we're talking about the transformation for sine functions. So we finish this topic. Thank you very much. Please subscribe my channel. Thank you. See you next time.